Okay, Assalamualaikum and very good evening. So today I will be presenting of my progress report submission for semester March 2023 to August 2023. So my name is Mohd Abdul Raup Parsat. I'm a student of a Doctor of Philosophy, Electrical Engineering, and my supervisor is a technologist, Dr. Dalina Johari, and my co-supervisor is a Professor in Senior Dr. Ismail Musuri. Okay, so in this semester, I did more in a literature review. I go I'll go deeper in the BFO and also shielding failure. So we start on the back flashover or BFO. So here's the parameter affecting by the BFO. So we have a four item of four parameters. The number one is striking a distance. Okay, so the striking distance is a lightning strike away from the tower. So when they are striking distance and lightning strike away from the tower, induced voltage magnitude magnitude on the insulator string is a decrease. So this is one of the parameter I found during my literature review. And my second parameters is a front and tail time of the lightning current. So small front time will cause more conductor flashover compared to the bigger front time. So front time are getting higher from 1.2 second, 1.2 microsecond to 10 microsecond. So this is due to increasing of the induced voltage and then insulator which will lead to the flashover. So this is when the exit of the critical flashover or say CO4. So there will be the flashover on the insulator string. All right, so number three or the third parameter is the peak of the lightning current. So this is obviously the more lightning peak current, the number of the flashover pattern. For example, in the two circuits, circuit one, red, yellow, blue, and the circuit two, red, yellow, blue also increase. So that means if the peak of the lightning current is higher, so the probability of the circuit one trip all the passes red, yellow, blue, or both circuit, which is red, yellow, blue on the circuit one and also red, yellow, blue on the circuit two. And the last item is the tower footing resistant to FR. So this is a quite obvious when the TFR and the TFR is high, the number of pressure will also getting higher. And then here's the three important of the voltage during the BFO. So we have three important voltage. Number one is the crest voltage VDT, and number two is a voltage at the top of the tower VT prior to the reflection from the TFR, and also the last one is a final voltage VF. And we can calculate the voltage VR and the current IR across the TFR as the upper equation below. So VR equal to Ri multiplied by ZT over ZT plus Ri, and for the current IR equal to ZT over ZT plus Ri multiplied by I equal to Re over Rf multiplied by I. And when they are the back flashover, the response of a zinc system is a difference during steady state and the high frequency or lightning. So this is quite obvious when they are lightning, and the zinc system, the response of the zinc system is a different during the steady state or the power frequency and also during the high frequency. And the occurrence of the soil ionization during a lightning, and the soil will act as a nonlinear when it is subjected to the high current discharge. As a result, a voltage gradient in a soil will be generated as the per equation below. So E equal to J rho. So J is the current density and rho is the soil resistivity. Okay, and we still in the BFO, so structure of the breakdown region in the soil when the impulse current has to pass into it. So when there's a lightning or when the impulse on the earth electrode. So they are the breakdown region in the soil. So whenever an earth zinc electrode is injected with a lightning impulse current, the soil adjacent to the earth electrode is ionized. So due to that, the resistivity of the ionized soil drops to a low value, and the D2FR would be reduced automatically. So as you can see, sorry, the breakdown region. So we can see here's the ground electrode, and the first layer is the arc region, and here is the spark region, and the non-linear region, and this is the normal region. So this is the process or the structure of the breakdown region when the impulse a current has passed into it. Okay, we move to the shielding failure, or SF. So it is simple. Lightning strike to the conductor directly and produce over voltage. So this shielding failure, flashover rate, SFFO, is related to the shielding angle, a tower head, and also landscape condition. So when we speaking about the shielding failure, flashover rate, SSFO, is related to three parameter importance. The first one is shielding angle, tower height, and also the landscape of the condition of the towers of all the transmission line. And the third one is a typical analysis method. So this is a typical what I found in during the literature review. So typically analysis method is using electric geometric method, EGM, a ladder propagation, and also Monte-Carlo method. So these three type of the method is actually the typical, or some of this combination between the of this method. And here is the recommended formula of the striking distance by IEEE. So if you want to calculate what is a striking distance, so here's the formula which is recommended by IEEE. So RC equal to 10 multiplied by I power of 0.65. So here's the RG, and here's the equation of the striking distance, where I is the lightning current amplitude. Okay, so tower located on the top of the hill mountain is easy to shielding a failure flash over. So that's mean if the tower located at the top, or maybe top of the mountain mountain and hill, so the tower is easy to experience of the shielding failure. And also not only the top, but the tower located on the valley or hollow, shielding failure flashover happen in the span. So regardless of voltage level, 66, 132, 275, and also 500. So tower located on the valley of hollow, so shielding failure flashover happen in the span. Okay, so I did also for my data or collection data. So this is actually the actual data from 2018, 2020, 22. So I divided into two categories. So the number one is a positive 15 shielding angle, and the orange one is a zero shielding angle. So the number inside the bar graph actually is the event of the line tripping. So as you can see here, at least the positive 15 degree shielding angle is occurs for each years from 2028 for event. For single circuit, SCT is a single circuit, DCT is a double circuit, and double circuit once in 2019 and once in 2021 and two in 2022. So this a positive 15 degree shielding angle actually is the unique transmission line in Sabah. So I just put the numbers, just put the data. So my idea is I can recognize the pattern of the shielding failure versus the zero shielding angle, which more to a back flashover. So soon, I will be provided the data for lightning peak current by using our LDS for each event. So this event for 132 kV and also 275 lines, kV lines. Okay, so this is the typical software being used in modeling of the lightning. So number one is EMTP, the famous one, electromagnetic transient program. And this is the analysis mode to traveling wave method. And the second one is the PSCAT EMTD. Third one is MATLAB Simulink. It's more to computation analysis. And the leader progression model LPM. This is more the analysis model of the simulating the physical process of the lightning development based on the lightning observation and research achievements of long gap discharge. And some of the researchers also use PSCAT for the grounding analysis, and also, as I mentioned earlier, electrical geometry model EGM. So geometric analysis method which combine the lightning discharge characteristic with the transmission line structure, dimension, and topography. Okay, so here's the sum of the modeling of the parameters. So the first, or the important one, is a power and transmission line model. So the importance of the modeling of the tower is actually the tower surge impedance, and number two, or the second, is insulated string as per equations, which is V flashover equal to K1 plus K2 over T of 0.75, where the K1 equal to 400. 400 multiplied by L. L is the insulated strength, and T is the time for elapsed after lightning stroke in a microsecond, and K2 is a 710 multiplied by L. And the modeling of the leader development. So this leader development is more to analytical formulation, and the leader development is calculated by solving a set of differential equations. So basically, three types of discharge development process. So these three important parameters. Number one is a current inception, and number two is a streamer propagation, and the last one, a leader propagation. Okay, so F1 also this discrimination of a BFO and also shielding failure. So they have 6 comparison item to be compared, which is for to back flashover and shielding failure. So we look in item number one, magnitude of the lightning current. So in BFO, of course, the lightning current is large, but in shielding failure, small lightning current. And the ground resistance, large for the back flashover, but a less relationship with the ground resistance. And number of the flashover passes for the back flashover multi-pass on the same tower or multi-pass on different tower. So this is obvious. And the shielding failure, a single phase on the single tower or same phase or adjacent tower. So this is a characteristic for the number of the flashover for the BFO and the SF. And number 4 is a topographical features. And of course, for the back flashover, it's a little influence, but for shielding failure, is easily happen on the slope or the top of the mountain. And the ground climb, we can see burn mark on the flashover, but not necessary burn marks for the shielding failure. And the last one is the flashover passes. For the back flashover, a low lightning distance level passes, and the shielding failure passes that easily to be struck by shielding failure. Okay, so others conference seminar that I contribute during my semester March to August is the number one is I participate, or I was a presenter for the paper lightning behavior in a Beaufort Sabah, and I present in Asian Pacific International Conference for internal conference online. In Langkawi, this is a 2023, Langkawi, Malaysia. And this paper also published by IEEE. So the conference actually is in June, 5 to 15 June. And second one was a participant in lightning protection in SSB as a presenter, also a presenter. And this is a conference for Joint Maintenance Cooperation Committee, JMCC, Phuket, Thailand. So this is a conference for the Asian Utility, which is from PLN Indonesia, ICAT, Thailand, Vietnam, EVN, NPT, CSB, Malaysia, Sarawak, and also TNB. So 6 utilities involved in this conference, and this conference in I think 2 weeks ago, 7 to 10 August 2023. And this is just a conference, but it's none for the publisher. So thank you. I think that's all for my progress report in this semester. Thank you very much.